In 1993, three engineers sat in a Denny's diner in San Jose, California, sketching an idea on a napkin. They believed graphics processing would become the most important computing problem of the next decade. Today, that idea is worth more than $3 trillion, and their company just became the most valuable company on the planet. This is the story of Nvidia. The three founders were Jensen Huang, Chris Malachowski, and Curtis Preem. Huang was a chip engineer at a company called LSI Logic. Malachowski and Preem were engineers at Sun Microsystems, working on graphics chips for workstations. All three saw the same opportunity. Personal computers were about to need dedicated hardware just to draw images and run video games. General-purpose processors were too slow for that job. So they founded a company called Nvidia and set out to build a chip whose entire purpose was rendering graphics. Nobody had really done this before. It was a bet that visual computing, not just number crunching, would define the future of the industry. The early years nearly killed the company. Nvidia's first chip, the NV1, bet on a graphics technology that lost out to a rival standard, and it flopped. The company burned through its funding fast. At one point, Nvidia had about 9 months of cash left and no clear path forward. Jensen Huang later said the company came close to running out of money more than once. What saved them was a brutal internal habit, killing bad decisions quickly instead of defending them. When Nvidia's next chip also struggled, the company pivoted hard, simulated the chip in software before manufacturing it to avoid another costly mistake, and shipped the RIVA 128. It sold well enough to keep the lights on. One of the moves that saved Nvidia in those early years came from an unlikely place: the video game company Sega. Sega was developing its own next-generation console and had chosen a different graphics partner, but Nvidia struck a deal anyway. Sega paid Nvidia roughly $5 million for a chip design that Sega ultimately never shipped in its console. For Nvidia, low on cash and racing against the clock, that money was the difference between survival and shutting down. Jensen Huang later called it one of the most important deals in the company's history, not because the chip succeeded, but because the cash kept Nvidia alive long enough to build the RIVA cards that actually worked. By the late 1990s, Nvidia had found its footing. In 1999, the company released the GeForce 256 and marketed it using a brand new term, the Graphics Processing Unit, or GPU. It was the first chip designed to handle the heavy math of 3D graphics entirely on its own, freeing the computer's main processor from that work. Gamers noticed immediately. Nvidia went public that same year, and GeForce became the card serious PC gamers wanted. For the next several years, Nvidia and its rival ATI fought an intense war over who could render the most realistic graphics, the fastest. Nvidia kept winning enough of those rounds to become the default choice for gaming hardware. But Jensen Huang saw something else in these chips. A GPU is built to do thousands of simple calculations at once, in parallel, which happens to be exactly what graphics rendering needs. Huang realized that same design could accelerate all kinds of other problems, not just games. In 2006, Nvidia launched CUDA, a platform that let programmers use GPUs for general computing, for science, simulation, and eventually artificial intelligence. At the time, almost nobody wanted this. Wall Street didn't understand it, and it cost Nvidia billions of dollars to build and support for years with barely any customers. Many people, including some inside Nvidia, thought it was a costly distraction from the core gaming business. Nvidia kept funding CUDA anyway, for over a decade, long before there was any proof it would pay off. That patience is what set the company apart. Most chip makers optimize for the next product cycle. Nvidia was quietly building software tools, developer relationships, and hardware capability for a wave of computing it couldn't fully see yet. Researchers in universities slowly started using CUDA to speed up scientific work, because nothing else could crunch parallel math that fast. It was a slow, unglamorous bet, running in the background while the company's public identity was still built entirely around video games. Then in 2012, everything changed. A team of researchers built a neural network called AlexNet to recognize images, and they trained it using Nvidia gaming GPUs instead of traditional processors. It crushed every previous record in the competition by a huge margin. That result sent a shockwave through computer science. Deep learning, a decades-old idea that had never worked well in practice, suddenly worked, because GPUs could finally give it enough raw computing power. Nvidia's gaming chips, originally built to render explosions and character models, turned out to be the perfect engine for training artificial intelligence. The CUDA platform Nvidia had spent years building for almost no customers was suddenly the only serious option available. Nvidia moved fast to capture this. The company redesigned its business around data center chips, purpose-built for training and running AI models, not just rendering games. Every major AI lab and cloud company became a customer. Along the way, the stock also got pulled into other booms and busts it didn't fully control. Cryptocurrency miners bought huge numbers of Nvidia's gaming cards to mine coins, inflating demand, and then crashing it just as fast when crypto prices fell. Nvidia's revenue and stock price swung wildly through the 2010s because of it. But underneath the volatility, the real, durable business was quietly becoming artificial intelligence infrastructure, and that business kept compounding. Nvidia's rise did not go unchallenged. Rivals like AMD built their own AI chips, and big cloud companies such as Google, Amazon, and Microsoft started designing custom chips of their own to reduce how dependent they were on Nvidia. But Nvidia's advantage was never just the chip. It was CUDA, the software platform Huang had bet on back in 2006. By this point, millions of developers and nearly every AI research lab had spent years building their tools on top of it. Switching away meant rewriting all of that work. That software lock-in, built slowly over almost 2 decades, turned out to be harder for competitors to copy than any single chip design. Then came the moment that changed everything again. In late 2022, ChatGPT launched, and the world suddenly understood what large-scale artificial intelligence could do. Every major technology company scrambled to build and train their own AI models, and every one of those models needed massive numbers of Nvidia's most advanced chips to run. Demand exploded overnight. Nvidia's newest processors, built specifically for AI training, sold out as fast as the company could produce them, with some customers waiting over a year for delivery. Nvidia's revenue more than doubled in a single year. Wall Street, which had once dismissed CUDA as a costly distraction, now called Nvidia the single most important company in the entire AI boom. By 2024, Nvidia was no longer just selling chips to individual customers. It was effectively selling the infrastructure for a new industrial revolution. Tech giants announced they were spending hundreds of billions of dollars building data centers packed with Nvidia hardware, betting that whoever controlled the most AI computing power would control the next era of technology. Nvidia's newest generation of chips, codenamed Blackwell, was designed specifically for this scale, built to train and run AI models far larger than anything that came before. Jensen Huang, still Nvidia's co-founder and CEO after more than 30 years, stood on stage at product launches describing a future where every industry would need this kind of computing, not just software companies. In June 2024, Nvidia briefly passed Microsoft and Apple to become the most valuable public company in the world, worth more than $3 trillion. 3 engineers who started with a napkin sketch in a Denny's diner had built a company that now sits at the center of the entire artificial intelligence industry. The lesson underneath the story isn't really about graphics chips. It's about a company that bet on parallel computing for over a decade with almost no evidence it would pay off, and refused to let go of that bet until the rest of the world finally caught up.